Okay, so I'm not entirely sure how to split the screen so you can see my face and the thing. So I'm not really gonna figure that out right now because I have too much to do. So you're gonna see my face first, hear my voice. This is me. And then I'm gonna start sharing my screen. Bear with me. This might show my face. Right. Okay. So this is my this right? Yeah. Woo. Okay, so this is exam one, take home part one. Sweet, so it goes like this. The total condenser distillation partial boiler problem. The partial boiler is 100% efficient. Start from the bottom, you know XP. You go all the way up, and then 75% efficient, and you're gonna keep going. That's how I did the red lines, but I'll start how I start from the beginning. You know XD, you know XP. You need to find Rmin. Find Rmin via the quality. I assume the quality was 0.5 because you said half vapor, half liquid. Interesting assumption, I know, but I'd made it anyway. So you find the feed line slope via the equation, and you get about -1. Put the thing in. The Rmin is going to connect to the equilibrium point intersection of the feed line to the XD, and from there you're going to find your all total by times that by 2.8, and then once you times it by 2.8, you find your R, and then you find your top operating line. You draw the top all around. You find your bottom operating line via the intersection point that you just found, and you connect it to your XB. And then from there, you're going to draw your stages. As I said, you want to start from the bottom because it's a partial boiler, which is 100% efficient and is not a tray, but it's a stage. And you go up 75% because it's 75% efficient. I eyeballed that because I did not want to do the actual math. You can't do the actual math by connecting the two, like looking at the actual range of the points here. Times it by 7.5, add it, or yeah, 70 was 0.75. And then I got five trays plus partial boiler if the total condenser counted, which I'm pretty sure it doesn't because it's a total condenser. So therefore it isn't a stage like it shouldn't be. It's like a point because it's just a total condenser. But if it was, it'd be the top thing and it'd be 4 trays plus a partial boiler and a total condenser. But I'm gonna say it's 5 trays plus partial boiler. For the V, I just did a mass balance on it. So it's like this thing. Um, I probably should have labeled it, but this is um D. Um, yeah, so it's F equals B plus D, and then FZ1 equals BXB plus DXD. And then I found that the reflex is L over D. Like I got that equation from my notes, and then I plugged it in and I got 193.8551. Next problem was in regards to two flash tanks that you didn't know the T drum for. There's a lot of mass energy balances in this one, and frankly, I was kind of sad. But that's fine. There was a component balance and a total mole balance, and you use your data to like put in the equation. Because you know L over F and you know V over F, and oh sorry, you know V over F, so you can get L over F via like this part with the total mass balance, and then once you get that, you can get L over F, and then from there, um, you can get uh, you can start solving things. And then once you solve like one thing, you can get your other one. So like x2 equals x1, or sorry, z2 equals x1. And once you solve for that, which I solved for down here, was 0.3. I looked at it and I went up to the line and it was 78. And so I said the first one was 78. And then the second one, I did more math like the same way I did it before, kind of. And it was also like an energy like a mass balance. And then I went up to get it to be around 84.4. And then I kind of just kept doing that for like the rest. Like L1, like the mole fraction 0.31. Like that's how I found all the mole fractions like from the graph, and the flow rates were like through mass balances. The next one, I used the enthalpy thing. So like AF HF plus Q equals LHL plus VHV. And then HF is you just need to find a heat of vaporization like pathway. Like heat needs to have a pathway. And I didn't want to mess with the units, so I just divided it by like the molecular weight. So it's like the component times the CPL of that component divided by molecular weight times TF minus TREF. And then I like did the math there, defined HF. Then once I found HF, I looked on the graph to get around 91 degrees Celsius. I think that's all I have to explain. Let me know if you have any questions. Sorry, this probably was like a horrible explanation, but I'm just done. I'm just did I just stop the recording? Well, bye bye. Thank you.